Hello, in this problem we want to examine whether there is a statistically significant difference between two treatment groups, and these treatment groups are called experimental and conventional. And I'd like to demonstrate how to use Statcrunch to answer this question. So a couple of things that we want to notice. The first thing is that the claim is that the new treatment, and if we read through the question here, the new treatment makes a difference, and so we should choose that appropriately. Next, the null hypothesis and the alternative hypothesis. The null hypothesis is always chosen so that it has the equal sign in it, or less than or equal, or greater than or equal, but it's the option that has some sort of equal quantity in it. So we're going to choose equal, and the alternative would be that they're not equal. And the claim, therefore, is the alternative hypothesis because it makes a difference. Okay, so let's move forward. Now, this next question asks us to find the critical values, and we're going to use a t-test here. Notice that this is a two-tailed test because we're looking at the means being equal versus not equal. So it's a two-tailed test, and our alpha is set at 0.02. So let's hop over to a t-table here. And we're looking at two-tail. So we need to go to the two-tail 0.02 column, and now we need to scroll down until we find the degrees of freedom that fit our problem. So let's go back over here and see what are the degrees of freedom. So we're going to count up the number in the first treatment and the number in the other treatment, and then we'll subtract 1 from each of those. In other words, we'll subtract a total of 2, and that will give us the degrees of freedom for both. So we got 1, 2, 3, 4, 5, 6, 7. So there's 7 in that group minus 1. So degrees of freedom is 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Minus 1. Degrees of freedom is 9. So total we've got 15. Back to our chart. Two-tailed test, 0.02 is alpha, scrolling down until we get to the degrees of freedom, and I did not mean to do that. Degrees of freedom equal 15, and we're looking at 2.602. Next, I'm going to look at the data in Statcrunch. So if we click on this little button next to the data, that will copy the data to Statcrunch. I've done that here. Click on Stat, T-Stat, to sample with data. The reason I'm choosing this is because we want to do a t-statistic, we want to do a t-test, and we do have 2 samples, and we have the data. So we have the actual numbers that were computed from or calculated from some experiment. It's not the case that we're giving the summary like a mean and standard deviation. We actually have the raw data. So the data are present in the experimental treatment column as well as the conventional treatment column. We'll click on Summary Statistics and Compute, and at this point we are given that the t-statistic is a negative 1.3937, etc. And we're also given the p-value. And so this is enough information to really decide whether or not we are going to reject the null hypothesis or fail to reject the null hypothesis. But I will add a picture here that I think might be very helpful. Okay, so I've put the data here on a visual so we can see what's happening. So if we have a distribution and we plot our critical or our cutoff values, those were here at negative 2.602 and a 2.602. And what that means is that out here in these tails, this is the rejection region, meaning if we get data points that that lie out here, those are so extreme and so unusual to just happen by chance. If we get data points out there in that extreme region, it means there's probably an effect going on between this experimental and control group. And so we're safe to reject the null hypothesis. And then that's why it's called the rejection region. So let me write that down. The rejection region lies beyond the critical values. And again, if you get an experimental or standardized t-statistic that lies in the rejection region, then you can reject the null hypothesis, right? You think, oh, there's probably something going on. I'm going to reject the null, and so then you can proceed with there. Now, in this particular example that we've been working on, our data indicated a t-statistic that was negative 1.39, and that does not sit out in those tails. It's not as extreme as this negative 2.602. So that's not very unusual. You know, some samples are going to vary a little bit, and so maybe we got the samples being a little bit different just by chance. It's not extreme enough to go around rejecting null hypothesis. So since our data point lies right in here at this negative 1.39, we are going to fail to reject the null hypothesis because our t-statistic is negative 1.39. It's not very unusual. It could have happened by chance.